Welcome back, Physical Science 20. This is the 11.1 booklet. So this is the booklet to help you complete all of the assignments that you have for FC2. And it corresponds to pages 308 to 312 of the textbook. So what we'll be looking at here, the objectives, define and give an example of the mole and Avogadro's number, describe how a mole is used in chemistry, relate a mole to common counting units, and convert moles to numbers of representative particles and number of representative particles back into moles. Okay, so first of all, if you think about certain words that we use in everyday life, one pair, of course, equals 2 things. A half dozen equals 6 things. 1 dozen is 12 things. If we get to very large numbers, 1 mole represents 6.02 times 10 to the 23rd things. So that's this decimal moved 23 places to the right. So it's a huge number. And since atoms are so small, we need a large amount of them in order to be able to work with them and change it into grams, things that we're used to measuring. So we're dealing with very large numbers because we're dealing with such small things here. This is referred to as Avogadro's number, named after Amedeo Avogadro. So 1 mole is equivalent to Avogadro's number, and that number is just simply 6.02 times 10 to the 23rd things. And it is used for converting between units. We'll look shortly at looking at converting it between atoms and molecules and moles, grams, liters, etc. So it's very helpful in doing that. Now, an important thing here in chemistry is distinguishing between molecule, atom, and formula unit. So if we look here, a molecule is a group of non-metal atoms bonded together. So those elements from the right-hand side of the periodic table, those are non-metals, and when they bond together, it is referred to as a molecule. So the group of non-metal atoms, molecule. For example, molecules of carbon dioxide. Atoms, just simply single elements. So iron, for example, copper. If I just have single elements, those are referred to as atoms. And when I have ionic compounds such as sodium chloride, a metal with a nonmetal held together by positive and negative attraction, that's not a molecule, it's not an atom, it's referred to as a formula unit. Okay, so those are the 3 units that we use here: molecules, atoms, and formula units. So by looking at the compound that you're given, you should be able to state the correct unit. Okay. Conversion factors allows you to go from one unit to another. So if we look at common conversion factors, let's say we're dealing with dozens here, or 5 dozen roses. Of course, we know that 1 dozen is 12 things, or 12 things is 1 dozen. So there's actually 2 conversion factors I have with this statement. 1 dozen is 12 things, or 12 things is 1 dozen. So 2 different conversion factors. So if we want to find out how many roses 5 dozen roses is, we would be looking at using this one here, because we want to end up with things, in this case roses, and we want to cancel out units of dozens. So if we take a look here, 5 dozens multiplied by 12 roses is 1 dozen. The dozens unit cancels, and I'm left with roses. Okay? So I use the idea here, whatever's on the bottom or the numerator should represent the previous unit. That's what's written right here. And the new unit I'm converting to should be on top. So obviously we would multiply by 12 over 1, as opposed to 1 over 12, because I'd get dozens times dozens, which is dozens squared, over things, and of course that unit doesn't make sense. And vice versa here, if we're going from roses to dozens, so how many dozens would 132 roses be? So we're going from roses to dozens, before, after. Before goes on the bottom, and the after goes on top. The old unit is on the bottom, the new unit I'm converting to should be on top. And if we set this up, 132 roses, multiplied by 1 dozen over 12 things. Roses cancel, and I'm left with dozens. So we can not only cancel numbers, but you can cancel units. Okay, and so similarly with the dozens unit, we have Avogadro's number and the mole. So 6.02 times 10 to the 23rd things, though those particles are atoms, molecules, or formula units to represent those numbers. Or I could say 1 mole over 6.02 times 10 to the 23rd particles. And by particles, again, I mean atoms, molecules, or formula units. So here, it says, see how to use the mole representative particles conversion factor by reading examples 311 to 312, then completing practice problems 1 through 4. We'll take a look at that, and hopefully we'll be able to get that. So if I take a look at the questions we're going to be doing here, this is right from the textbook. So number 1, 2, and 3. We'll go through number 1 together, and then I'll set up number 2 and 3, and you'll be able to work through that one and see if you can get it. So determine the number of atoms in 2.5 moles of zinc. So we're going from the number insinuates here moles of zinc to atoms. Moles of zinc to atoms. So if you notice here, moles of zinc to atoms. So moles is my old unit, atoms is my new unit. So on top I should have atoms, on the bottom I should have moles, so that's this one right here. Particles over moles. And of course I can be more specific about what the particle is. It's atoms. So setting that up, 2.50 moles of zinc multiplied by 6.02 times 10 to the 23rd atoms over 1 mole. So you can see the moles cancel, and I'm left with atoms per unit. Multiply this out, and I get 1.51 times 10 to the 24 atoms of zinc. There's 3 significant digits, so I need to have 3 significant digits here. Okay? And when doing this in your calculator, 6.02 times 10 to the 23rd, this is the format here, 6.02. Now in your calculator, you should have an EXP button or an EE button. Whatever one you use, that button means times 10 to something. And that something is 23. So use the EXP button or the EE button to do the times 10 to the part. Okay? So work through that. Make sure you get that answer, whether you're using a calculator or an iPhone. Make sure you get that answer. Okay? Questions 2 and 3, I'm going to show you them here, the questions. So take a look. And I'm going to end the video there because I want you to try that to see if you can figure out the conversion factor and work it out, get your answers, and then you can check your answers on part 2 of this video. Okay? So get these questions and then try them out. Okay? We'll see you soon.